Let's check out what's going on with these cell phones, all right? So attention on the board, please. First, it says estimate. How many, or H of 2006. So who can tell me what H of 2006 equals? Who can tell me what it equals? Sean?
Like 85% of people about had landlines in 2006.
Yeah, so for the explanation, it means 85% of people in 2006 had landlines at their house, right?
I said 80.
So you'd have some writing about that. I'm just going to say it. Okay. And then who can tell me what C of 2006 means? What is it? What's the estimate and what does it mean? Cam?
About 50%, and it means that in 2006, about 50% had cell phones.
Yeah, those are the two places we're looking. In 2006, about 15% of people had cell phone only. Yeah, Vin. Next, what's the approximate solution to get to C of T equals 20? What do you got, Brennan?
I got in 2008.
Yeah, I'm looking at that spot right there. So I'm going to write that in function notation. I'm going to say C of 2008 equals 20. And in context, what that means is in the year of 2008, 20% of people had cell phones only. Okay? Even I couldn't have been that. When I was in college, our dorm had a wired phone as well, and we all had cell phones. So I would have been on the landline phone edge of that, even as a hip, upcoming college student with a Justin Bieber haircut. Okay? So,
Yes.
number 3. Let's see if these are true. So number 3 says in 2011 it's the same. So let's go check it out. I'm referencing right here. 2011. Are they the same?
Nope. No.
A, you lied to us. Okay? Next, in 2015, are they the same?
Yeah. I would say
Right there, right?
so. Apparently.
Check. I know that it's the same because that is the intersection of the two lines. They're both right around 50%, right?
55. That's when that changed.
I would say 50.
So, between 2004 and 2015, did the percent increase of cell phones only match the percent decrease of landline only?
No.
So this is, yeah, what do you think, Abe?
Yes, because if you add the two percentages up, what you get is 100. So one decreases the other one.
Yeah, in general, so it might not actually exactly equal 100 because here's the groups that aren't on here. Landline only is not on here.
Yeah, it is.
No, it's landline phones. Cell phone only. So landline only is not on there, and both isn't on there. But it sounds like those are going to be some really small percentage. So let's justify this with some math using our average rate of change. So let's just focus on cell phones first. Okay, so to find the rate of change for cell phones from 2004 to 2015, I know in 2015 I'm close to I don't know. It's less than 50 though. Let's say 48%. You guys good with that? It's a little less than 50. So it goes 48%. But where did I start for cell phone only? Would you say about 4?
Yeah.
4%? Okay. And what's my interval of time?
Years.
Yeah, 2015 minus 2004 gives us 11 years. So what this tells us is it went up 44% in 11 years. How much is that per year?
4.
So up 4% per year. That's my average rate of change. That's what our warm-up was today even, right? Is everybody good with that? Now let's look at the decrease. The decrease, it ended up at 48%. I'm just going to do 48. But where did it start? In 2004, where are we at? Like 94? You want to do 94? Let's do 94. That's where we started. Okay? And my interval for time is still the 2015 minus 2004. So this means it went down. How much did it go down? You guys can't tell me how much it went down? Yeah, negative. It went down 46 over an interval of how many years? 11 years. Well, guess what? That's really close to. Really close to -4%. So like, it depends. This would probably be like
I said they just.
how you answered this question.
They're
If you showed me this math and said it's not exactly the same, so no, I'd probably be like, okay. Or if you said they're pretty close to each other and you showed me this math, I'd be like, and you said yes, so yes, I'd be like, okay. So what's gonna make this
There
one?
would be no wrong answer.
There would-
That's,
There would be. If you just said yes or no and didn't justify it with numbers, it would be
so
wrong.
this is a,
And this
a lot of people are
problem
gonna
probably
get
won't be on
I-
the test.
I would lead myself to say, yeah, as one goes up, the other goes down. They're really close to each other, right? Because numbers a lot of times in the real world don't end up being exact, right? So that's what I'd be inclined to say. But if you justified it with your numbers, I'd be all about either answer if it made sense. All right, anybody need this up any longer? Okay. For this problem, you've got 3 graphs of shows. You also have A, B, C, D. You have 4 situations of shows. So how many situations extra do we have? Okay. You have 3 graphs. We have 4 situations. How many extra situations do we have? So one situation doesn't have a graph. You'll sketch that on number 3. So you and your partner get after
Number-
the audience of TV shows. Let's go. So let's look at A. Show has good audience. They have a guest star on the 5th episode that makes it go up. A, B, or C? Who can tell me?
I'd say the wrong.
All right, Sean.
C.
C, so let's check it out. Pretty good audience. Bam, 5th show. And it petered out again. All right. B. One of the most popular shows, and the audience just keeps on growing.
D.
Who can tell me which one?
E.
Raise your hand.
It's none.
Livia.
A.
Hey, so
Oh.
here's one thing. I also was like, oh, it's increasing. That looks good. But does this start with a strong audience?
No.
No, so it's tricky because look at our y-axis.
0.75 mil.
Look at our y-axis. It's different. But it's got the correct trend.
Only about 7.
So this one's missing. This is the missing one. Okay?
Do it.
Let's go to C. Small audience, but improving.
I would say that's A.
Let's go look. Small audience.
But it's improving.
It's improving. Okay? And then D.
E.
Started out huge. And even though it feels like it's not as good, it's
It was
still
10
kind
mil.
of
10
big. Whoops.
10 milli.
Let's see. Started huge, but even at the low point, still like 4, right?
3 phone.
Yeah. That's pretty good. So the only thing you need to do to graph that missing one that started strong is you just need a y-axis, something like 2, 4, 6, 8, 10, 12, where we're starting. It can look similar, but we need to change our y-axis to make it accurate. We good? We good. This one's just kind of straight up. You're going to answer these questions. Focus on getting answers in function notation. On your homework and on your quiz next week, there's going to be a bunch of function notation stuff, all right? All right, let's take a look. So the first place I'm looking, f of 2 and g of 2. So I like to draw like a vertical line like this, kind of. And I'm looking at here and here. So which one's bigger? G of 2. F of 4 or g of 4? The correct term is samesies. F of 6 or g of 6?
F of 6.
F of 6.
Quarterback counts.
F of 8 or g of 8?
I would say F of 8.
F of 8. Is there a value where they're the same? Z's. Looks like,
F of 9 and G of 9, and F of 4 and G of 4.
so we're going to write it like this.
I need my counts.
All right? I got too many spots on here now. These 2 spots are the same, right? So at least 2 values. Well, guys, there's like a bunch. In fact, theoretically, there's infinite. But anywhere here before you get to where they intersect, and then anywhere here after they intersect would be valid. And you're going to use an X value for that, right? I just drew a hat, son. Didn't even plan on it. It's a solid hat. I'd wear it.
According to my counts.
Let's finish it.
According to my coach,
You know what I say, when you start something, finish it, okay?
Make it pink.
There we go.
Oh, something.
There we go. That's it.